Hello everybody, and welcome back to video 7 in our series of going from zero to hero cadence development. In this video, we're going to talk about resources. Now, this is a extremely important topic on Flow, arguably the most important topic out of every video we're going to be covering in this series. So if you're going to pay attention to one and not fall asleep, this is the video to do that. Yeah, let's get right into it. So remember during the first video, I mentioned that one of the Cadence pillars was resource-oriented programming. This is exactly what we're going to get into here. So if you hear resource-oriented programming, it's because of this thing called resources. So resources are a type, and in Cadence, resources, have a bunch of properties. And we're going to kind of walk through the documentation here and look at exactly what resources are, and then we're going to jump into some code and start testing around with what they are. So you'll see that resources are types that can only exist in one location at a time and must be used exactly once. So this is different from structs, normal variables. You can declare a variable x, just leave it in the function. But with resources, they can only exist at exactly one location. They can't be copied, and they must be used. And we'll see what that means in a second. The second thing is that resources must be created using the create keyword. We'll see that in a second in the code. Another thing is that at the end of a function which has resources in a scope, the resource must be moved or destroyed. So this means that if we pass a resource into a function, we have to either then move it somewhere else or destroy it. We can't leave resources just dangling in the middle of a function. And this is different from other variables because, for example, if we passed a string into a function, we could just leave that string there. It doesn't matter. With resources, we can't do that. They have to be kept track of. And then the last thing that I kind of wanted to go over is that resources can be explicitly destroyed using a destroy keyword, and so we will also look at that in a second. And also, just before we jump into code, I will also mention this, but resources, are a type. But in order to actually explicitly see that it's a resource, you would put this @ symbol in front of it, and in order to move resources back and forth, we'll use this arrow. So that's just a heads up when we start actually getting into some code. So let me actually launch a Flow playground here, and we're going to walk through some basic syntax. So I'm going to set up a contract just called pub contract resource stuff, and we're going to start defining a resource. So in Cadence, a resource is actually defined using the resource keyword. So public resource, we're going to call this hello. And we open up our resource here. So just like a struct that we saw in the previous video. Now I'll note that resources always have pub. It's the only access modifier they use, the resource keyword, and then hello here. So inside this, we're going to define some variables and functions even. And so I want to make it clear that resources are almost like a container. It's a container of stuff, almost like pretty much like a struct, except they're much more secure and much more unique. So in here, we're going to specify a greeting, public like greeting. This is going to be a string, and we'll just make an init function, which we have to do in resources, similar to structs, and just say that self.greeting equals a greeting that we actually pass in right here. So let's do this. Let me actually turn off my air conditioner that just came on. Okay, so this is it's like a container that holds this greeting variable. Now let's actually make a function outside of this resource called create hello. And what this is going to do is it's just going to be a normal function. And actually, why don't we return, well, let's not do that yet. So in this function, if we wanted to make a variable x that was just 2, right, we would say, variable x maybe is an integer, and this equals 3, right? And then if we ran this function, nothing would happen, right? This x would just be there, and it would disappear after the function's over, whatever. But if we actually want to create a resource, now let's say variable test resource. What you have to do is you have to actually, instead of saying, and we'll actually specify the type, which in this case is @hello. And so what the @ means that this is a resource type. And so every time you put a resource type, you have to put the and in front of it. And what we can't do is we can't just say it equals a hello, like you would do with a struct. So if this was a struct, let's change this to a struct. This would actually, if we got rid of this and, this would actually work, right? If we passed it a greeting, but it's not that. It's a resource. And so we can't just use this equals thing. In order to create a resource, we have to use, in order to actually move a resource into a variable, we have to use this arrow. And what this arrow means is that we're going to take whatever we put over here that we're going to do in a second, and we're going to move it into this resource. So you have to move resources. You can't just say equals. All right. And so in order to actually create a resource, you have to say create space and then the name of the resource and then whatever things we want to pass in here. So let's actually take in a greeting for this function, and we're going to pass that in as the greeting right here. Okay. And so what we've done is we have created a resource and moved it into this variable. All right. Now you'll see it says loss of resource. And remember, if we go back to the documentation, it says at the end of a function which has resources, the resource must be either moved or destroyed. And so when we make this resource, we can't just leave it dangling in the middle of this function. Cadence is saying, no, you have to do something with it. And so let's do something with it. Why don't we return it? So what we can do is we can specify the type that we're returning is a resource hello. And let's return it. So again, you can't just say return a test resource. If you're moving resources around, you have to explicitly move it with a arrow. And so again, just to kind of make sure this concept is really solid in your head, when you're moving resources places, you have to use the explicit move operator. And this is because resources are so much more secure than things like structs, right? You can't just say equals, you can't just return it. You have to explicitly say where you're putting the resource so we can't lose it. So you'll see it's impossible to lose resources unless, let's say we were to not do this. What we could do instead is destroy the resource. And of course it's complaining because we're not returning, so we can just get rid of that for now. But this destroy keyword is a built-in keyword that when you put a resource next to it, means it just destroys the resource, so it no longer exists. Okay, cool. So the next thing I want to do is actually to show you what happens if you put resources inside of other resources. And so just as a quick note here that I want to talk about, I'm sure that you can kind of start to see why NFTs on Flow are such a good idea and why the Cadence programming language was built around resources. It's because when you think of things like NFTs, right, that are secure non-fungible tokens, right, there can't be duplicate, tokens, they're non-fungible. In code, you're actually seeing this represented with resources. Resources can't be copied, they have to be moved around, and it's almost impossible to lose them. So you can see why building NFTs on Flow is such a good idea. It's because it's so secure around those resources. And so we could actually use resources to represent our own NFTs, and we'll see that in a future video. But cool. All right, this is good. So the next thing I want to do, like I said, is to show you a collection of resources. So let's actually do that. Let's do public resource hello bucket. And so this is going to be a bucket that holds hellos in it. And in order to actually do that, let's do a public var hello. Let's do hellos. So these are all the hellos. And this is going to be a dictionary that maps a uint64 to a hello resource. Now, this is something I want to touch on in that when you have a resource type inside of a dictionary, or let's say that we had made this an array of resources, you have to put an and in front of it. So you wouldn't put the and here, which I know is a little confusing. You would put it here, and this says that this dictionary contains resources. And similarly for an array, you would put it outside. Okay. All right. Cool. So what this says is that we're gonna map a uint64 to a hello resource, and so it's complaining, missing initializer. So let's actually initialize this resource. And what we want to do is say self.hellos, and we can't put equals, just trying to really make this concept solid. We have to say move, right? So we're moving things around, and it's because that this dictionary contains resources. So whenever it has something to do with resources, you always got to use this move. And then it's also saying missing destructor for a resource field. So remember I said that resources have this sort of implicit function that's a destroy, and all it does is destroy the resource. Well, when you have resources inside other resources, you get this problem, and that it's that the implicit destructor doesn't know how to destroy these resources inside of it. And so we actually have to define the resource again, the destroy function again, and in it we have to put destroy self.hellos. so that if we were ever to say something like, destroy hello bucket, it would call this function and destroy the resources inside of it as well. So that's something to note if you ever see like missing destructor for a field or something like that. Okay, so let's actually go down, and we're gonna down here we're gonna make another function, public function, create hello bucket, and inside here we're not gonna take in any parameters. We're gonna open up this function, and what we're gonna do is say var test hello bucket. This is going to be a hello bucket, and we're going to create a hello bucket. Okay, cool. So we've created our hello bucket, right? And so what we can do is we're actually just going to return this hello bucket, and we're going to start getting into some transaction code so that we can, see exactly how to do this. And remember, we have to put our move operator here. Okay, so what I'm going to do is uncomment this, and make sure that we're returning this again so that we can actually start testing this in a transaction and figuring out how to actually store hellos inside of a hello bucket. So let's deploy. You'll see that it deployed our contract. And also, I know that some of you may be like, well, where's your init function in the contract? Well, if you don't have any state, like variables for your state, you don't have to put in an init function. But we could, if we wanted to, just put our init function here, and we can redeploy this contract just to make everything more clear. Okay, so we've deployed the contract. Now, let's go to a transaction, and let's import resource stuff from account 0x01. And we're going to log done when we're actually done. Okay, so what we can do is inside this execute, what we're going to do is we're going to call that function, right, create hello bucket. So we want to create the bucket first, and it's going to return to us a hello bucket. So if we go inside our transaction, we're going to say var bucket is going to be a @hello bucket. And we're going to move, something into here, right? And what we're going to move is resource stuff. I spelled that wrong. Resource stuff. And what this is going to do, and then dot create hello bucket. Okay. And so this type, remember, has to be resource stuff dot hello bucket, because this doesn't know what that is, right? It has to be of the type of the contract. Okay. So it's complaining loss of resource again, because we can't just leave this resource here. We have to do something with it. But essentially, we can ignore this for now because we're still working on our bucket, right? So we now have this hello bucket, and so we want to store some stuff inside of it. And so let's actually do that. So what we probably should do is we should probably define some sort of function inside of this hello bucket to actually deposit our hellos here. And so let's actually do that together. So let's make a function that we can call on this bucket to actually put hellos inside of it. So let us say a public function deposit hello. This is going to take in a hello which has a type of hello, and inside of it we're going to say self.hellos. And then, what you would normally think, actually, let me take a step back when I'm explaining this. So one thing I also want to talk about with resources is the unique identifier for every single resource. And what I mean by this is that resources in Cadence all have an implicit field called a UUID. It's a UUID. And what this is this is a unique identifier for every single resource in Cadence. So if you had a contract and I had a contract and someone else had a contract and your friend had a contract and all those contracts were creating resources, every single one of those resources has a unique identifier called a UUID always. And so no resource on the Flow blockchain is the same. Again, ties into how NFTs are really easy on Flow, right? Because NFTs are unique identifier, stuff like that. But what we can do is the UUID actually has a type of uint64. So we can actually use that UUID to store, the hello resource, and then the key to get that resource is its unique identifier. So let's actually do that. So what you would think you would do is something like this: self.hellos at hello.uuid equals the hello resource, right? You know, of course, because it's not actually the equals, it's the move. But you can't do this. And so this is a whole other topic when it comes to resources in Cadence, is that when you have a dictionary that holds, you know, key value mappings like this, and you'll see this everywhere on Flow, which is why we're talking about it. Um, when you see a mapping from a key, like a UN64 to a resource type, you can never do something like this. And the reason for this is because remember when I said that resources are super secure, you can't lose them, Flow makes it so difficult for that to happen? Well, think about what would happen if we did this, right? Of course, you know, this is sort of a bad example since, you know, no resources will ever have the same UUID, so it's impossible to actually, like, it's impossible for something to ever already exist here anyway. But think about a scenario where we were mapping, like, I don't know, like strings or something, you know, and it was possible for that string to be, you know, the same across different resources. You know, if we were storing it based on, like, a name or something. Think about how dangerous this would be, right? Because we would be moving a resource into a place where a resource might already exist. And this is very dangerous because then we would overwrite that resource. And remember, we don't want that to happen, right? If, well, let's say that resource is an NFT that's worth $2 billion and we just overwrite it, that would be terrible. And so what you have to do is actually do two things. And so this is the first way, and then we'll also go over the second way. So the first way is literally just to add this you know, force operator here. And what this means is that if something already exists at this you know, mapping, then panic, abort the program, and don't do anything. So just reset everything that happened. So this means that, you know, if we did a bunch of stuff in our transaction and it aborts the program, it'll undo everything. The second option is to do, and I'll just comment this out for now, is to actually define a variable called var old hello, move the self.hellos at hello.uuid out, and then in that same line, move our new hello in. So this is a very kind of complicated thing, but think about what happened here. What we did is we defined an old variable called hello. We moved the old hello into it, right? And then we moved our new hello into this key mapping. And then, of course, after this, we would just destroy old hello, and it would be fine. But, you know, in this case scenario, this is a little more loose in the sense that, you know, if something did exist here, then it would be moved into here. And so if we wanted to, you know, then we could take that old hello and maybe like return it or something so that we didn't destroy it. But you'll see this syntax a lot. And so if you see this double arrow, that's exactly what it's doing. And oftentimes, if you're looking at like an NFT contract, you'll see they just destroy the NFT afterwards, which is, you know, kind of a weird thing to do because then you're just getting rid of that resource. But these are the two separate ways that you can do it. And so just for the sake of this example, we're going to go with this one since it just looks a lot, you know, cleaner. Okay. So we've done this. We've defined a deposit, and let's actually deploy this contract. So we've deployed it. Let's go back to our transaction, and you know we have our bucket here. Let's refresh the page just to make sure it's all good. Okay. So what we're going to do is we're going to now say bucket dot deposit hello, and we're going to actually create a new you know, hello resource here. And so remember, you know, actually, well, I didn't mention this yet, but this create keyword can only be called inside the contract. So if we tried to, let's do something down here where we say var hello, and we actually try to call that, right? So we move a you know, resource stuff, or no, we do create resource stuff dot hello. Look what happens. Well, we should comment this out because it's giving us an error. And let's say we were just to pass in a greeting that says like hello, right? Look what happens. It says cannot create resource type outside of containing contract. So you cannot use the create keyword outside the contract, okay? All right, so we'll get rid of this. So this is exactly why we have defined a function called create hello that creates it for us and then returns it, right? So inside of this call, we're going to deposit a new hello that we create. So this is going to be resource stuff dot create hello. And it's asking us for a greeting, so we'll just say like I don't know, hello. Okay, cool. So we've deposited a new, oh, and we have to move it, remember. So if we create a resource, we then have to move it into this argument label, okay? All right. And so now what we're going to do is we're going to, you know, let's see if we can even, we actually can't log a bucket, but what we can do is we can say log bucket dot, I think we named it hellos, and we can do dot keys or something, and so this will return the keys of that dictionary inside of our resource, and then afterwards, we can destroy our bucket. And so that way there's it's not left dangling, right? So let's run this transaction. You'll see it logs a 1. Now what we can also do maybe if we wanted to is log values, and so this will be a better maybe this will be a better example. Um, okay, so look at this problem. So it says field values is not available for resource dictionaries, and think about why. It's because of the fact that if we wanted to just get an array of all those values, think about what would happen. It would return an array of all those resources, but that would mean they would be copied, and so that's terrible, and so it doesn't let you do that. So what you would have to do is you would have to define a function in here to return all of our, hello, um, all of our hello greetings, and so that would take a little bit of time, so we're going to skip that for now. But what we can do just to make sure that our resources are actually staying in there is to do dot keys. And let's just make a bunch of these lines, just create a bunch of hellos. And so now when we run this transaction, you'll see we get a bunch of, identifiers. And so these are all the unique identifiers for those resources, which is super cool. So we will use a very similar functionality when we go into NFTs, and we'll see that instead of a hello bucket, this will be an NFT collection, and instead of a hello, this will be an NFT. And so we'll work with these when we start getting into NFTs. So I just want to make sure that I didn't miss anything that I wanted to talk about, but I think I did everything that I wanted to talk about. Cool. And so if you have any questions about this, then please go to the flow documentation, go to the resources page, and you can read up here or make a comment on the video. Thanks so much for watching, and I'll see you in the next one.